Okay guys, let's continue 2.7. We should probably finish it in this. All of the previous videos, mostly background information. We have one more thing to talk about, translations, and then we'll see what the types of problems you might see on your homework. So vertical translations are vertical shifts, are when your function moves up or down from a certain point. So if we talk about x squared versus x squared plus 5, we know our regular x squared parabola. By now we're probably kind of sick of seeing this thing. So x squared plus 5 is the same thing, just moved up 5. So instead of starting at 0, 0, I start at 0, 5. But I maintain the same general shape. It's just all shifted upward. By shifting, again, the y values, we shift the range of the function. If I take this and move it up 5, I can no longer go from 0 to infinity. I've now added 5 to both of these, so that would be from 5 to infinity plus 5. But since infinity is a concept, it's really still just 5 to infinity. So again, anything vertical can affect the range. Anything horizontal could affect the domain. So given f of x, if you have f of x minus c, we call this a horizontal translation of f of x. So notice, positives move this function up vertically, negatives move a function down. It is the opposite for horizontals. It's actually minus signs that move it to the right and plus signs that move it to the left. So if I take my normal square root of x and I instead change the function to s squared or x plus 5, that's really a minus negative 5. So plus 5 moves it to the left 5, because of course it's opposite. So positive really moves it to the left 5. Then we do the same thing again. And even though these look close together distance-wise, they are still always 5 apart. So what this does is it also shifts the domain left 5, which instead of going from 0 to infinity, because the only numbers I can plug in here are non-negative, I can now plug in a few of the negative numbers from negative integers. We can plug in infinitely many negative numbers there, but that's a different comment for a different time. I can plug something like negative 4 in here now and still get a positive under the square root because I have to add 5. So what this generally means, though, is that it will affect the domain. Just like the reflections can affect the domain and range, translations can affect it as well. Now, generally speaking, these rules, the vertical stretches and shrinks, the reflections, and the translations, all affect things. So we'll talk about how this will work in a problem. But the order you really need to apply them is probably reflections first, then stretches and shrinks, and then translations. The reason that you need to do it in that order is it has to do with your order of operations. If you move something up or down and then reflect it, all of a sudden you're reflecting your movement as well. If you're stretching it, you're stretching your movement as well. That's kind of like the problem we had with that absolute value equation in the last video. So you need to keep that in mind. So I generally tell people to do reflections first, talk about what kind of reflection it is, talk about the stretches or shrinks, and then talk about the translations. So let's look at a few problems. Describe the following transformation given the parent function. So given your original function, f of x equals the square root of x, describe the transformation required to get g of x equals negative 2 times the square root of x plus 3 minus 5. So first off, this negative in front of everything means we've got a reflection. Now, what axis is this across? This is across the x-axis because this is in front of everything. This is the one that flips it up and down. So that gets us to f of x equals negative square root of x. I like to keep track of what things I've accounted for when I'm going through it so I can see what's left. This 2 in front is a vertical stretch by a factor of 2. You can usually say by the factor of whatever that number is. To me, there's some debate on the shrinks, what you should say. For example, some people like to say it's if there was a 1/2 in front, a shrink by a factor of 1/2. Some like to say it's a shrink by a factor of 2. This is more a semantics question, because if you shrink by a factor of 1/2, that's like a double negative. To shrink by a half kind of has a double negative connotation. So, but I won't count either one off. You can either say it stretches. When you're stretching, it should be stretching by a positive factor. When you're shrinking, you can say shrink by the fraction, or you could say shrink by the reciprocal of the fraction. But that's an aside. If you just want to do it like this, that's totally fine. Okay, so now we have the translations. So the +3, we have a horizontal. It doesn't matter which order you do the translations. Translation. The +3 means we're actually going left 3. And then we have a vertical translation, or you can call it a vertical shift. If you want to say horizontal shift and vertical shift, this is down 5. Now, how does this help us? If I know what the original graph of the square root of x looked like, I can see how these would change. We had originally square root of x. The negative square root of x flipped me upside down. -2 square root of x did a stretch by a factor of 2. And my translations just move me. So instead of my starting point starting there, my starting point started 3 to the left and 2 down. So this would have been right here. This now starts 3 to the left and 5 down from here, but the same shape. So the idea is we can use this for graphing if we don't want to plot all the points. And if we can use it for graphing, we can also look at the graph and tell what kind of equation we have. So if you ask yourself what kind of shape this looks like, well, it kind of looks like the absolute value, right? But the absolute value starts at 0, 0 and goes upward. So the question is, the first thing I'm looking at is a reflection. Do I have some kind of reflection? Yes, it looks like I need to reflect downward. So in order to do that, if we reflect downward, let's see what happens. We have this thing. So this is negative absolute value of x. Now, it looks like I need to judge the steepness to see if I need to have a stretch or shrink. But it looks like we have the same steepness as we have in our final answer, the purple one. So the only thing I really need to do is go left 2 and up 2. So we know left 2 means I actually have to have a plus on the inside of the function. To go up 2, I need a plus on the outside of the function. So this is something that you just kind of have to practice and get used to, but you can do it with any parent function. And this is really all for 2.7.